Imagine a rocket worth millions of dollars launching into space at thousands of kilometers per hour. Most people believe that once its mission is complete, it falls into the ocean, destroyed forever. For decades, that was true. Every launch cost hundreds of millions because the rocket could only be used once. It was like building a brand new airplane for every flight, then throwing it away after landing. It sounded normal until one company asked a simple question: what if a rocket could come back not by parachute, not by crashing, but by landing itself, standing upright, ready to fly again? At first, people laughed. Many experts said it was impossible, but today SpaceX has made reusable rockets a reality, launching into space, returning through Earth's atmosphere and landing with incredible precision, sometimes on a tiny ship floating in the middle of the ocean, and sometimes back at the launch site. It looks like science fiction, but it's one of the greatest engineering achievements of our time. So how does a massive rocket travel to space, then find its way home without a pilot? And how can it survive a journey that pushes technology to its absolute limit? Today, we are uncovering the incredible engineering behind SpaceX's reusable rockets. The journey begins long before the countdown. Thousands of engineers spend months designing, testing, and inspecting every single part of the rocket. Nothing can fail because even the smallest mistake could end the entire mission. Standing more than 70 meters tall, Falcon 9 is powered by 9 Merlin engines. Together, they generate over 7,000 kilonewtons of thrust, enough to lift hundreds of tons off the ground. As the countdown reaches zero, the engines ignite, flames explode beneath the rocket. The ground begins to shake. Within seconds, Falcon 9 rises into the sky, accelerating faster every moment. It punches through thick clouds, battles powerful winds, and climbs higher than any airplane could ever fly. But here's the incredible part: the first stage has only one job: to lift the rocket out of Earth's thick atmosphere. After just a few minutes, its fuel is almost gone. At that moment, something remarkable happens. The rocket splits into two separate sections. The upper stage continues towards space, carrying the satellite or spacecraft, while the massive booster begins an entirely different mission, not forward but back home. Now the booster is falling from the edge of space, traveling at thousands of kilometers per hour. Gravity pulls it back toward Earth. Without control, it would break apart or crash into the ocean, but this is exactly what it was designed for. Moments after stage separation, small thrusters fire slowly, rotating the booster until it faces the correct direction. Next, 4 titanium grid fins unfold near the top of the rocket. These fins act like the wings of an airplane. They don't provide lift. Instead, they steer the falling booster through the atmosphere every second. Onboard computers analyze its speed, altitude, wind conditions, and exact position. Thousands of calculations are made instantly. Tiny adjustments keep the booster perfectly aligned with its landing target. As it falls faster, the air becomes thicker. Friction builds rapidly. The outside of the booster heats up, yet it continues descending with incredible control. Then comes one of the most critical moments of the entire mission: the engines restart in midair. This is called the entry burn. It slows the booster before it enters the densest part of Earth's atmosphere. Without this burn, the forces could become too great to survive. As the booster continues its descent, the target comes into view. Sometimes it is a landing pad near the launch site, other times it is a drone ship, a floating platform hundreds of kilometers out at sea. Landing on a stationary pad is already difficult. Landing on a platform moving with the waves is something else entirely. The margin for error is incredibly small. Just a few meters can mean success or failure. As the booster approaches the landing zone, its computers take over. Human pilots are far too slow to react. The rocket must guide itself. Sensors, radar, GPS, and onboard navigation systems work together to determine its exact position. Every movement is measured, every correction calculated instantly, then only seconds before touchdown, a final engine ignites. This is known as the landing burn. The rocket, which was once falling at enormous speed, begins slowing down rapidly, carefully, precisely. The engine produces just enough thrust to fight gravity, not too much, not too little. For a few moments, the booster appears to float balanced on a column of fire. Then its landing legs deploy, locking firmly into position, and finally, after traveling to the edge of space and back, the rocket touches down, standing upright, ready for another mission, a maneuver that once seemed impossible. But landing the rocket is only half the story. The real goal is to fly it again. After recovery, the booster returns to SpaceX's facilities. Engineers inspect every engine, every fuel line, every valve, and every sensor. They search for even the smallest signs of damage. If needed, components are replaced, software is updated, the engines are tested again. Only after passing hundreds of inspections is the booster cleared for another launch. This changes everything. Instead of building a completely new rocket for every mission, the same booster can fly again and again, saving millions of dollars on each launch, reducing preparation time and making access to space far more affordable. This breakthrough has transformed the entire space industry today. Launching satellites, supplying the International Space Station, and even preparing for missions to the Moon and Mars has become more practical because rockets no longer need to be disposable. What once seemed impossible is now a routine part of modern space engineering. SpaceX isn't stopping with Falcon 9. Its next goal is even more ambitious, a fully reusable Starship, the largest and most powerful rocket ever built. Unlike traditional rockets, Starship is designed so that both stages can return, land safely, and fly again if successful. The cost of reaching space could fall dramatically, making missions to the Moon, Mars, and beyond far more realistic. One day, thousands of people may travel beyond Earth using rockets that launch, land, refuel, and launch again, just like modern airplanes. A dream that once belonged only to science fiction is slowly becoming engineering reality. The next time you watch a SpaceX launch, remember, you're not just watching a rocket leave Earth, you're watching one of humanity's greatest engineering achievements. A machine that defies gravity, returns from space, lands with incredible precision, and proves that impossible ideas can become reality. This is more than a rocket, it is the future of space travel. If you enjoyed this journey into the engineering behind reusable rockets, don't forget to like, share, and subscribe, because here on RailForge we explore the world's greatest engineering marvels. Space technology, mega projects, scientific breakthroughs, and the incredible machines shaping our future. Every documentary takes you behind the scenes of technologies that are changing the world. Thank you for watching, and we'll see you in the next engineering documentary.